recording. Okay, do you see my screen?
Mm-hmm.
All right, so I just want to give a couple of examples here to kind of help you see how we can break this up. So I'm just going to go do a couple of examples here. Let's say I had graph 1 of y equals x squared. And then let's say the domain for this is x is less than -3. Okay.
Mm-hmm.
Let's say I had graph 2. Let's say it was y equals absolute value of x minus 1. And this is showing between let's see. Hold on a second. Oh. Okay, so let's say x is between -3 and 3. Okay, and then I have one more graph here. Let's say graph 3 was y is equal to square root of x minus 2, but I'm only going to show this graph to the right of 3. Okay, so this is a condensed version of what you're doing here, but let's put all these 3 graphs, create them separately, and see how they merge, or how we can get them to show in the piecewise function. So y equals x squared is just a parabola. I'm just going to create a graph here. And if I were to go through order pairs, -1, -2, -3. -3 is all the way up at 9. Were you using Desmos?
Yeah.
Okay, yeah, so Desmos helps. It gives you all the order pairs you need, so it's nice.
Mm-hmm.
Okay, so here's the full graph, but we're only going to show the graph to the left of -3, so only this part is going to show up in our piecewise function. So let me just highlight that, and then we can come back to that when we need it.
Okay.
Okay, absolute value of x minus 1 looks like this. It has a vertex at 1. It extends like this. But we only want to show the graph between -3 and 3. So -3, if I were to plug that in, it'll be at 4. And then if I were to plug in 3, 3 minus 1 is 2. Okay, it's not drawn to scale here, but okay, so if I only want to show between -3 and 3, then I only want this to show up in my piecewise function, because this is the graph that shows up between -3 and 3. And then finally, absolute value square root of x minus 2. The graph looks something like this. And I only want to show this graph to the right of 3. Even though the graph starts at 2, I only want the graph to show to the right of 3. So if I plug 3 in, 3 minus 2 is 1, square root of 1 is 1. So a piecewise function will ensure that we don't have any overlaps, because we're only showing the portions of the graph that are within each region, and they're not going to ever overlap each other. So now if I put the highlighted portion onto the same graph, there's my piecewise function. So to the left of -3, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is where my starting point is, and it's going to go like this because I'm eliminating the rest of the graph that is not part of the domain. And then this is going from -3, 4 to 3, 2. Again, not drawn to scale. And then I want this part of the graph to show. This is starting at 3, 1. And there may be some overlap at these endpoints here. So to ensure that we don't have a full overlap is you just make one a closed circle and the other one an open circle. It doesn't matter which one, so that it'll ensure to pass the vertical line test.
Okay.
Okay, does that help?
That helps a lot. Thank you.
Okay. All right, any other questions?
Not really.
Okay, so I just reset your project, so I think you'll be able to resubmit it.
Thank you so much.
All right, take care. Have a good day.
You too.
Bye.